Everybody, thanks for coming back. I'm Paul Gill from Western Power. All I'm going to do this afternoon is sort of try and stage manage this bit for you. We've got Jeremy's presentation and then Mark's to go. On the agenda, they run one, then straight into the next one with a discussion period at the end. What I think I'm planning on doing is we'll listen to Jeremy's presentation. We'll probably have 5 minutes of questions on that to get any specific... You're taking questions. Just to get any specifics out and make sure it's in our minds before we move on to Mark. Do the same with Mark and then have a discussion. The discussion isn't like the morning one. There's not a bit of paper for you to fill in per table, and it might be you decide to get together on some tables rather than all be spread out, or you can just shout at each other. It doesn't really matter, but we'll work that out when we get to it. So, Jeremy.
Good afternoon. Well, as long as you shout at each other and not at me, that'll be fine. So I was asked by Paul to just put something together on low voltage cutouts as to see where and what the industry is doing in respect of its strategy associated with it. So some of you are probably already aware of what we're doing, but basically the purpose of the cutout is to provide a safe and reliable supply terminal to properties, to protect it from faults on the network, means of connecting suppliers to the buildings, de-energising and isolating supplies, and also appropriate an earth connection. So for those that aren't in the industry as such, that wants to know what a cutout is or a service termination, these are a few examples of them. So typically the more modern one on the left there, but it's not limited to any D&O. You know, I think there's several cutouts or service terminations that we use across the industry, but these are certain types. And obviously the middle one there is for a three-phase one, and these are generally what you find in house properties. So the demarcation of responsibility. So for a distributor or a D&O, the cutout is where the demarcation is. So everything up to and including the cutout is generally the responsibility of the D&O. Then it goes, the tails then go out to the meter and the consumer unit. So this is the guidance that we took from the MACOPA for service termination. So so you can see the meter, the consumer unit, what the customer looks after, what the D&O uses, and the supplier. So it's as simplistic as we can probably get it. So the legislation under the SQC, Electricity Safety, Quality and Continuity Regulations, basically says that the equipment is sufficient for the purposes and the circumstances for which it's being used. Constructed, installed, protected, both electrically and mechanically, so as to avoid danger, and inspected with sufficient frequency. So the supplier and meter operator has a duty to comply with the requirements of the distribution connection and user agreement, the MACOPA Code of Practice, and also the SQC regulations. So that underpins everything where everyone comes from. And another regulation, don't worry, it's not all about regulations, it's just sort of setting the high-level tone and disclose such information between each party so that we're running it safely and ensure that we're both compliant with the regulations that we've said before. So the two principal hazards, fire or short circuit, flashover. So, you know, those are the most common activities that could happen with a service termination, and the scenarios associated with that could be an overload, so people that have installed more equipment and not advised the supplier, whether there's some abuse or malicious operation of the equipment, so if someone's tampering with it, you know, it could potentially cause them harm, and effects of the environment. So if it's in an outside box and the doors come off and no one's reported it, the weather could get in there, or if it's under a stairs and is continually being knocked with some activities, then it could be an issue there. So, you know, all of those sorts of things are important to be aware of in when we go and inspect it, or when a meter operator goes there and advises of what's what. and additionally also our chaps as well. Craftsmen can go there, do some activities as part of a shutdown or something like that. They could see a box on the wall where a cover's broken. So there's things that we can do ourselves as we carry on our normal activities. So some of the mitigation activities, the design is making sure that all the designs, you saw the different cutouts, they're vast and varied in respect of how they're built for the different activities. So it's making sure that everything that is designed is to a British standard. It's also appropriate for the location it's going to be in. So if it's designed to go outside, it should be an IP rated, or if it's inside, it should be commensurate with what it needs to be and where it needs to be for ventilation and things like that. So some of the other things, operations and use, is making sure that everyone is qualified to actually use the equipment. It's not just, Joe Bloggs goes along, thinks that they know what they're doing, which, unfortunately, going back to the tampering, it can happen. Someone pull the fuse, not put it back properly or interfere with the integrity of it. So it's making sure that, where possible, everything is sealed to make sure no one tampers with it. Those are easy signs to look for when we visit sites to make sure that nothing's been changed. Condition monitoring, making sure that when people go there to site to look at these bits of assets, that we make sure that things are as they should be. There's no sort of hot spots. The sticker's not peeling off and bubbling, where it may have got excess heat. Certain things like that, just to make sure that everything, and if there is a reactive response that's required, it's done in the appropriate time. There's 3 levels, that we've got in place. A, B, and C, we call it simplistically. 4 hours, 48 hours, and several weeks, depending on what the issue is associated with the equipment. So planned maintenance and replacement. So modernisation programs that some DNOs have had in place. Some over the years have put a wholesale cut-out change program, service termination program in place. Some cutouts pre-1937 had a fuse neutral, so there was an active program there to change those from those to a more modern type. Because the danger with that is if you lose that, then there could be excess faults within the property, and it wouldn't necessarily be protected, for safety within the place. So. There's all those sorts of initiatives that have occurred as well. But also the records. So the thing with the meter operators now, the more information we can get, with charging points, heat pumps, any voltaic cells, all of those can add to the load going through the service termination. So the more information we can put in our asset registers as to what's going on in the property, the better. So there's an awful lot of continuous improvement. I've taken this from various ENA documents as to exactly what we're trying to do and how we're trying to do things. So, the DNOs are comfortable with the appropriate mitigations that are currently in place, but we want to improve. Continually look for new ways in which we can monitor. Smart meters is potentially one way in which we can see usage. There may be ways in which, going forward, smart metering may be able to help with condition of assets, going forward into some sort of version 15 of the smart meters. I know there's several versions already gone out that are smart, but not smart enough to communicate with the wider world in a format that we necessarily want. So there's always ways in which we can look at improved benefits associated with that. So some of the risk mitigations that is already in place and others are pursuing is sample auditing, inspections around certain types of cutouts, certain types of properties which may or may not have additional, so you've got photovoltaic, heat pumps and things, just to see how the cutout and the terminations are acting, gathering the details associated with that. So when a member of staff goes to the property, they may notice that there's a lot of load there, potentially electric vehicles, just to make sure that everything is appropriate there. Any termination that's failed is looking for forensic examinations to see what the root cause of failure was. That's a very important thing, is to understand and learn from those, so any future mitigations can be built into the design of any changes. And influencing future design through different engineering standards, through the working groups throughout the whole of the DNO arena. So that's a quick summary of service terminations. Thank you for listening. And apparently I've got 5 minutes of questions if there are any. But David, you don't need to ask.
How you sort of leveling out that risk and what you're going to base your inspection on. No, I think it was slide 12, you said gathering key pieces of information. What do you consider are the key pieces of information you'll gather?
The inspection could be based on any intelligence that's come out from the DNO working groups. So you could look at a certain type of termination in a certain environment, could be more hazardous than another type. So it's looking at those sorts of scenarios and learn from each other's experiences that could also then come from some of the forensic examinations that have also occurred. So it's almost weighting some of the activities, the environments, the types of properties or load that's been experienced to see whether there's any further degradation of the asset that you would normally expect to see in certain other types of scenarios. And it may well do, but again, it's what benefit or what added benefit you may find from doing those sorts of things. It could be that one of them is a sample inspection, to see whether the intelligence throughout the whole of the DNA environment is actually finding those same things. But a property in a box near the coast, you might find that the salt corrosion is causing more of an issue, which you may need to then target. So you sample that around the country near the coast to see whether it's the same sort of scenario.
I'll ask a question. We've got the microphone. What is the difference across the country, across DNOs, in terms of the defects that they report? Is it purely based on customer numbers? Everyone's reporting the same thing, or are there any regional variations because of the history of this equipment?
The different categories of defects are ranked A, B, and C. So within each of those categories, it defines this type of if there's an exposed part of the cutout that's potentially that's an A. Someone needs to go there straight away. If it's something a bit of conductor that's come back, or it's slight cracking. Everything has got a different time frame as to what needs to be done and when. So it's clearly articulated in the Macopa dialogue that the meter operators and we use. So there's a common methodology across the whole of the industry.
Jeremy, Ian Burley from HSE. In the near future, or maybe far future, all the meters will be obviously smart. What do you think the ESQCR definition of inspected with sufficient frequency looks like in that time frame?
Yeah, answers on a postcard. I think it'll be something to be decided as part of the working group, and the outcome of the working group as to what's defined as appropriate. I think I'll probably leave it as that at the moment, and it's probably not been completely defined until we know exactly what the smart metering rollout and what we find from it, and the outputs of that activity.